Good evening. My name is Jim Kello. Welcome to New Tracks, where mentors can help modelers build. Thanks so much for coming this evening. Hope you enjoy the show. Tell your friends about us so that they can join us too. If you're new to the show, please go and subscribe at our website, newtracksmodeling.com. You'll receive an email, and if you'll confirm the email address is correct, then you're fully subscribed. You'll be able to get all of the login information for our future shows on both Zoom and YouTube, as well as be eligible for the door prizes. We have two door prizes coming up in shows this month. One of them is August the 25th by Coastmans Scenic Products, and the other is August the 28th by Nick Santos' Dakota Buddies. So I know that you'll want to be here for those prizes, and that'll be August the 25th for one and August the 28th for the other. Keep in mind too that as of September the 1st, we're only going to be doing these shows on Wednesday evening and no longer on Saturday. So we have the shows in August for the next couple of Saturday evenings, and then we'll be off the air on Saturday starting September the 1st. We just don't have the volunteers where we can continue twice a week shows. And we're just having to cut back to the Wednesdays because the comments that I received from you, the modelers on the show, was you would prefer a Wednesday show if we can only have one a week to a Saturday show. So that's what we decided to do. We're also having to eliminate the individual breakup of our shows on YouTube, again, because we just don't have people to volunteer to do the editing of the show. So we'll have the full show, as always, on YouTube. So if you miss it, you can view it later, but we won't have the individual segments any longer. And if we get more volunteers, if we get people that are interested in helping us, we can reinstate these things, but we can't do it with the number of volunteers that we have today. We have some great build-alongs coming up. Rick and Marie Hunter going to start September the 1st with an 81-foot trestle. They're giving a good discount for it. Al Collins is giving a discount on his Ultimation equipment that will be useful in building the trestle. And all of the details on all of these, not just Rick and Marie's, but all of these that I'm going to mention now are on our website. So you can get all of the information, the contact information for the companies and everything, and exactly the dates that these are going to be. Rick and Marie are going to be here from September the 1st weekly through October the 6th. All of the rest of these will be between 4 and 6 weeks. So the start dates that I'm giving you, then if they're 4 weeks, there'll be 4 dates starting from that date. Martin Brechbiel is going to be starting one on September the 22nd. Leadbill Designs kit. It's a maintenance of way car, and that'll probably go for 4 or 5 weeks. Jim Murphy is going to be building a LaBelle woodworking business car in HO starting October the 13th for somewhere between 4 and 6 weeks. Both of these cars have great discounts. You have to mention New Tracks for both of them to get the discounts when you order them. If you don't do it when you order it and come back later and say, oh, I forgot, you're out of luck. You need to do it as you order these products. And this, again, these manufacturers are doing this to support the show and support what we're trying to accomplish here, which is to get you building more models. That's why we're doing these build-alongs, to try to help you see how to build the models and to build along with the builder on the show that's actually doing the work. So in addition to Bill Murphy and the others, Bill Davis is going to be building a rail scale tobacco barn. And this is available in all of those different scales. It's got a 20% discount. The one difference that I'll mention here is that the coupon code is New Tracks, but instead of 2 words, it's all 1 word. So the code is available not right now through October the 30th, but again, it's only 1 word, New Tracks. Then we've got Dave Schultz, who's going to be building the all-nation waffle-side boxcar. There are 2 versions of this car. One of them is a more detailed car with a complete detailed interior in it and some options for the roof. The other is a more basic kit. The basic kit has a 5% discount. The more detailed car does not. Since All Nation is a fairly new company, just coming back onto the market after years being off the market, the new owner is trying to get everything up to date. And he asks that you order these cars if you want to build along with Dave as soon as you possibly can, because he's having to make the cars and package them and mail them to you all himself. And this takes a lot of work for him. So if you're interested in this, please order it as soon as you can. And the same goes for all of the kits, to give the manufacturers as much advance notice as you possibly can give them. Our next My Build is August 21st. The moderator is going to be Jeremy Wyatt. If you'd like to participate, and we hope you will, send a photo and with a caption for the photo and your name to Jeremy, and he'll include you in the show. If you'd like to come on the show live that night and do it, that's you're most welcome, and hope that you'll do that. If you can't do that, then Jeremy will show the photo that you send, and also read the caption so that people will know what the model is all about. But we hope that you'll be here in person, and we hope that you'll be able to share it yourself on the show. This to me is a major part of mentoring the other modelers that may not have the same level of talent that you have, may have more talent than you have, but they'd like to see what you're doing. They'd like to be able to maybe compare in their mind what they're doing to what you've done. They'd like to talk to you about it. They'd like to see it. And that's what mentoring is all about. That's what this show is all about. That's the real purpose of doing it in the first place. I've been told the way that My Build is structured is too structured. We ought to be able just to open the show and say, if you want to show us some models, show us the models. And if somebody does, fine. If it takes 5 minutes, 30 minutes, an hour, no problem. But right now, I'm inclined to stay with the format that we have, and see if we can't get people to come on and show during the allocated time that we have for this. And we'll see how it goes on the 21st, which is this coming Saturday. So I hope you'll participate. If you've got a modeling question, we've got a form on our website. You fill out the form and send it to me. I'll find somebody to answer it. One example was we had one modeler send in a question about taking a car that maybe wasn't anything that anybody would want anymore, maybe cutting off the molded detail on it and converting it to a much more detailed car. Well, we have coming up on the 25th of this month, James Schultz, who's going to do just that and show you how to do it. And he's going to show you a car that he spent $2 for and what he turned it into. And this is an O scale. So that's not a bad value for a car that I think once you see it and see what James has done to it, you'd be proud to have on your model railroad. Now I'd like to stop a minute and turn to Paul Thomson for his quick tip of the evening. Paul, welcome.
Great, thank you, Jim. Tonight is going to be slightly different as far as getting my screen up, if I can find where this thing is. Screen share. Okay, here we go. Okay, what you're looking at there is a rotating cap on a roller bearing truck. And this happens to be a tangent one. And the way this came about was I had to replace these things, and because I'm switching to the 088 axle, and as you can see, the 088 wheel is on the right and the 110 is on the left. So you can see there is a bit of a difference, not a lot, but there is. And I have also included the NMRA gauge there, just so that you know every time you switch wheels or pull things apart like that, check your gauge. Now, what happens here is you've got an axle that you can just pull straight out. If you just lift straight up or straight down, if, depending on what your orientation is, you then end up with an axle with this little cap on the end, which I have taken off. And that is an easy thing to do. You just grab the little cap and pull it off the axle. No problem. But putting the other one back on becomes a bit of a problem. And believe me, I tried all kinds of things to pushing it back on, holding it with my fingers as I'd taken it off. That doesn't work. Tweezers, etc., don't work. So the way I came up with is set the thing flat like this. You can see where there is a small little hole in the middle of this thing that you're trying to line up to. Line it up with the hole with very little pressure. All you have to do is just set it, find the hole, and sort of orient it. And make sure also that you have the right side of this little cap going the right way, because frankly, if you try and put it in on the other side, there is no hole and it's very frustrating. Ask me how I know. And then at this point, keeping everything totally vertical, and the camera has sort of made this look a little not vertical, but putting everything vertical, then press down and friction will hold it on. I believe this stuff is made out of Delrin, and I don't think there's any glue that would do it. It's strictly a friction fit. So from that point, you then reassemble the thing, and here we've got the caps on the axle, as you can see, and they would fit into the two little slots here, and you just press them back in and your job is done. And fortunately with Tangent, when you buy one of their cars, they give you extra caps, so if the thing does come off, you've got an option. That basically is my tip, guys. Just remember that sometimes the simplest way is the best, and all the other little tools and gadgets I had just didn't work. It was just a case of line it up and make sure everything was straight. And that's it for tonight. Thanks.
Paul, thanks so very much. That's a great tip. I also might mention while Paul does these every Wednesday and Ted Becker does the quick tips normally on Saturday, both Paul and Ted have told me that they would welcome other modelers to offer the tips either Wednesday or Saturday and get involved in providing the quick tips, so that it's just not the two of them that are responsible for figuring out a nice tip for us each week. So if anybody would like to participate in this, then you just contact Paul or Ted and tell them you'd like to do a quick tip, and they'll make arrangements a Wednesday or Saturday at your convenience to do it, so that more people get involved in providing the tips that maybe Paul and Ted have never thought about and could help us all. The other comment that I would make before we start the show really tonight is Paul and James Schultz and David Schultz are going to do a roundtable soon on P48 and try to talk to us about what really is involved in P48 and the track that's involved and the detailing of the track and making the track a focus of really the detail modeling that goes into building the model railroad, much more than frankly I've ever thought about before. So I'm happy that they volunteered to do the P48, which is the O-scale version. And I'm looking for some people that would want to do the P64 and talk about the P64 as it relates to S-scale modeling, like P48 does to O-scale modeling. So if you're an S-scale modeler and you model in P48, or you're thinking about modeling in P48, or P64, I'm sorry, then please let me know, because I'd like to set up a round table of 2 or 3 modelers that model in P64 so that we can all benefit from finding out about it. I've been an O-scaler for many, many years, and frankly, I know absolutely nothing about P48. So I'm looking forward to learning about it. And I think a lot of S-scalers might also be interested in learning about P64. So if you're involved in it, please let me know. With that said, I'd like to turn to our special segments for this evening. That being with Martin Brechbiel, MMR, who's going to build us a car. Martin, welcome. You building in P48 or P64?
Doesn't really matter. It's O-scale. What size trucks and track you put under it in O-scale is up to you. So let's see if I can get this to work. I have a whole new computer, new camera, new everything on this. And 24 hours ago, I wasn't sure this was even going to work.
My gosh, you've got gray hair. I didn't notice that.
Hey, I got hair. Leave it alone. I'm not even using the right monitor at the moment, so this is a little complicated for me at the moment. Let's see if we can get this going. So, come on, you can do it. There we go. Hey, that looks familiar. It should.
Yes.
I just made it a couple hours ago, so it ought to look familiar. Okay, so scratch building cars. Well, it says scratch building. This is half scratch building and maybe 80% scratch building and 10% salvage and 10% seat of the pants modeling. So we're starting with this. Whatever this is something I tried to sell for 2 years unsuccessfully for a mere pittance at the one of the O-scale meets. Nobody wanted it. Nobody took me up on it. And at that point I said, well, I'm either throwing it away or I'm going to have to do something with it. And do something means make it presentable, turn it into something. I don't know what it's going to be, but we'll get something made out of this otherwise piece of junk that many people probably would just throw in the trash can. And you can see this is an old, whatever it is, it's got nails hanging out of it, visibly sticking out of it. It makes it a little hazardous to handle, but that's the way O-scale was once upon a time. It was all nailed together with actual nails, hammers and tongs and anvils and all that good stuff. So we got nails hanging out of the back side of it. We don't have back or front. We don't have walls. We don't have scribe siding. It's a semi-blank slate to work with, which I look at and say, this is great opportunity. I can do whatever I want with it. There's no rules, nothing engraved in stone. I don't have instructions I have to follow. I can do whatever I want. So this is off to whatever your imagination permits and whatever supplies you have laying around in your shop. So these are kind of fun things to do, and you find stuff like this under a table at a show, maybe $5, $10. It has potential. You can turn it into something interesting, and I hope that's what I succeeded with this. So we'll go forward from here. Look at the underbody. It says it's a reefer floor. Yeah, it's not a reefer, but okay, it's reefer floor. Those are Walther's parts from a long time ago. So this may or may not have been part of a Walther's kit or somebody's kit bash, or somebody bought Walther's parts and slapped them on this onto a reefer floor and started building. Doesn't matter. First thing, well, get rid of the nails. They're a hazard to life and limb. We put the sides back on. They're all glued into place. We got some trim boards, and those windows are reseated, which actually came out pretty decently. They're not in bad shape. They're white metal castings. They match the holes that they're in. I'm not going to cut new holes and fit new windows. They'll have to do. Okay, so we added ends. We added a door. There's no point in not having a door. It needs a door. Putting a new end in, put the door in, put the door trim in. Put the trim over the ends, cap off that end grain so it doesn't look like end grain, so you can have a nice solid piece of wood over it. Put some corner brackets, cut those around. It's just styrene. I've been actually using a lot more styrene in the last couple of weeks. It may be a fad or something, but I'm guessing styrene modeling is here to stay finally. We'll see if it catches on or not. Strip off the Walther's bolsters. I put my bolsters on because I like mine better, and I think they look better, and they're tapped and drilled and tapped for 440. So, and we've taken an end mill on the Dremel and just cut this out. So now I can put a KD coupler in. And these brass channel side sills, they were nailed on, but a little CA glue, a little bit of goo, some more nails, tapping them in tight, resecured those as well. I'm just going to keep those. I think they're more interesting than taking them off and replacing them with something else. Okay, we built up a whole new underbody. Wood center sill stock, 33 thousandths train line and brass wire, run that through, drill holes through everything. A lot of fun threading that through, as you might well imagine. Nothing like an S curve in brass wire through fixed stationary resin bolsters, which were drilled after the fact. Makes it more adventurous that way. Brass K-brake casting on supports. So we have lots of brackets and added bits of wood to hold it all together. So it looks a little bit more interesting, not quite so naked. Okay, so we had the rest of the car deck. What are we going to put on the rest of the car deck? And I thought, well, let's put a tank, a shortened tank, but a tank nonetheless. And we'll put something, do something interesting with this. So this is just 10 thousandths brass, K&S brass, rolled up around the dowel, clamped with a hose clamp, and those are low bow tank car ends. A venerable name and O scale. Take out your torch, solder it up. Now you have a tank. Leave a little hole in the bottom so you don't have a sealed system while you're heating it up. It's a little safer that way. There's nothing like, you don't want to solder up what amounts to a bomb in your basement. It's a low bow tank car dome. I actually got a handful of these brand new in the bags at the last O-scale meet back in April. So I thought, good time to use them. We'll just solder that up. That's 5 or 6 pieces. You solder it all up, drop it on there, touch it with a torch with a little bit of flux and some solder, you're done. And these are some old rivet strips I had. I got them in copper, got them in brass. After they're painted, they all look the same. I just wrap those around and put them in place with a little CA and glue. I didn't solder them in. They're so light, I'm afraid to actually hit them with a torch that I'd probably dissolve them, melt them down. Okay, so build a cradle for the tank car out of some strip wood, lots of nut, bolt, and washer castings everywhere. Cover up all those nail heads that were in the side sill. Add a ladder, some roof details. This gets mounted. There's a mounting plate at the bottom of this tank with a hole in it. And what secures it is a sheet metal screw from underneath. So it's removable if I really want to take it off of there. And I actually do want to take it off of there to paint it. It's a lot easier to paint as a standalone. This is just 16th inch angle that I made railings out of, and it's all soldered together and soldered to the side sills. That brass channel actually came in handy to solder to. So it's all nice and one big soldered together unit. And just a scene from the other side so you can see what it looks like from this angle. Started putting in some grab irons on where they can go. Grab irons on the end sills. You're drilling white metal. It's about a number 60 or a number 59 drill bit with precision scale, or this, I guess those are like 30 thousandths, so, or 33 thousandths wire grab irons. But a little trick is to dip your drill bit in some cutting oil and take your time with it. Otherwise, it's a great way to snap off a drill bit. Not so much a problem when you're drilling wood, but that soft white metal grabs those drill bits very, very quickly. Okay, the whole brake system's now in place. I made the brake hangers out of some brass stock. These are my resin brake levers. The little clevises are made out of 3/4 parts of a Grant Line turnbuckles, and there's that sheet metal screw I was talking about. So it's hidden inside the center sill. Unfortunately, it's got a very modern Phillips head, but it's easy to find, so I can take it back out. And we've got stirrup steps all the way around the car now, and air hoses at each end. So first pass painting, take it out in the garage, out in the driveway, take the tank car apart, take it off, give it a quick coat, black paint, 2 or 3 coats from every direction possible. We'll come back and finish it up later, but now we know what it looks like. We know where we're going. We get to finish the roof. And another view from the other side. Unsurprisingly, it looks the same from that side. Scale coat paint that I just happen to have a rattle can of freight car red. Not quite sure where I got that from now, but it comes off a little glossy, unfortunately, or fortunately, depending on what you want to do with it. Got the roofing in, my usual Panera napkin and 50% tight bond glue. There's about 100 pieces of paper there. No, not that many, maybe 30 pieces of papers overlapping and in between all the pieces, but it's all glued down. That gets a coat of Lark light gray, I think, on this particular car. And we're into the home stretch. We've got roof grabs. We've got a smoke jack up here on the roof. Marker lights, just for fun, because I had a pair of them laying around. Dry transfers. Okay, so that's what I was talking about. Scale coat becoming on gloss. I'm using dry transfers. They don't like gloss. They prefer a flat surface or a matte surface. So I actually like to use a clear matte spray from Rust-Oleum as opposed to dull coat, sort of in between the two. I like to finish it. It gives me trucks and couplers, brake wheel on the end through here, ties into the other system from underneath. There's what it looks like from the other side. View from the roof. So we've got that painted. And oh, there's another view from that end. What do you know? I made a lot more slides than I thought I did. Up the ratchet of Paul casting actually got added onto this. I think I added a little bit of styrene here to give it a little more platform for it to rest on. And the back end, a little touch up on paint and the marker lights. And that's where we're done with this car. So that was a salvage exercise, but you know, mainly it starts off as salvage, but then it's a lot of scratch building in between. And instead of a car that I tried to sell desperately, now I have a car that I have to keep because I have too much separation anxiety involved in it to sell it. Unless somebody waves a pile of money in my face, I can probably be purposely bought if need be. So next week, we're going to look at an adventure, the All Nation Caboose adventure. And Jim mentioned that John Wobbles revived or resuscitated All Nation. John sent me 2 different boxes of parts for the caboose. No instructions, no pictures, just 2 boxes of parts, and said, "Tell me what you think of this." So it was spread it out, figure it out, and seat of the pants modeling again. But I'll be back next week with that. So if I got any questions, now's the time to throw them at me.
Yeah, Chris Blackmore here. You mentioned early in your presentation a end mill drill bit that you use to cut out
Oh,
that
yeah.
white metal. I'm not one that is a machinist. Can you show me or tell me what that thing looks like?
Oh, gosh. Not easily. I'd have to run into my shop and find it.
Okay.
But if you want me to actually run in my shop and grab it, I'll do that.
No,
That's 30 seconds at most.
Hey, Mark, maybe you could show us, maybe you could bring it with you next time.
I can always do that next time.
that'd be wonderful.
Okay, let me make a note to do that, or otherwise a week from now, I'll have no memory of this at all. Yeah, okay. Yeah, I put that into my little variable speed drill press, crank it up and ratchet everything down tight and just run it through that until I'm happy with what comes out. It's just as I said, sort of, it's seat of the pants, but it does work if you're careful and slow.
Okay, well, I do have a drill press and a Fordham for the press and stuff, but I'm not sure of the bits and how to use some of the bits. So that's
I'm
tutorial
probably
I've always been looking for.
I'm probably using it wrong, but it works, which for me is okay. I'll work with that too. I can, I'm not properly trained on anything like that. The machinist I used to know and used to go to for advice is probably rolling over in his grave, literally watching me do things. But it works and it gets the results. And I have all 8 fingers and both thumbs, and no blood was spilled during this project that I'm aware of. So it's doable.
Well, super. Thank you.
Oh, glad to.
Anybody else? Well, Martin, to start with a $5 purchase, that turned out to be a beautiful car with a little effort and a little creativity.
Yeah, let me unshare you. Oh, I've been unshared. Okay.
So I really do appreciate you taking the time to show us what's really possible, because a lot of these things that you can find at shows and so forth like that, people just don't pay any attention to. They walk by and say, "Nah, that's a throwaway. No point in working with it."
Lots of fun stuff out there. If you want to take the time, you can make something really interesting.
Thanks so very much.
All right.
Well, now I'd like to turn to Ted Becker, who is our featured modeler. And Ted is going to talk about something that I'm interested in because I know absolutely nothing about it. And that's Arduinos and how to use them in your modeling. And Ted is familiar with the technology and understands it and is, I guess, an expert in it. So he volunteered to talk to us about it. And Ted, I really do appreciate this. I'm looking forward to trying to find out a little bit more about the technology, and hopefully I can figure out how to use it.
Okay, did I get unmuted?
Yeah, but I can't hardly hear you.
Yeah, that's been a problem, and I don't know how to increase the volume. Is this better now?
Yes.
All right. Okay. All right, we got the Arduino logo on the main screen.
Yes.
Okay, good. Did it change?
Yes.
All right, good. All right, the purpose of this clinic is to give you an overview of Arduino, show you how you can do it and how to learn more, show you what I have done with Arduino on my layout, and hopefully inspire you to try them. And included in that is going to be a description of my homemade network. Some history about me. Got my first Lionel train set in 1948. I received an HO train set in 55. built my first layout in the basement in 57. Got a BS degree in electrical engineering. Later on, I got a Master of Software Engineering degree. Did my first professional microprocessor work in 77. It was a device for payphones, if you remember them. Some of the first ideas about a model railroad network with a bus stuff was around 1989. I was briefly involved with the LCC working group in 2008, and finally got moved into our new house in 2008 and did my first microprocessor application to a model railroad in 2009. Experimented with servos and switch machines. Discovered Arduino 2011 at the Sacramento convention. Hooked those together with servos in 2013. Presented my first clinic on using servos in 2015, and the first installation of my network was in 2016. What is Arduino? Who's it for? What can it do for me, and how can I do it? Those, I presume, are the questions you really want to have answered, and I will attempt to answer them. What is Arduino? Well, it's a family of microcontroller boards and a software system that supports them, that allows you to program them. Originally were developed in Italy with the intent to make microcontrollers available, more accessible to students and artists and hobbyists. Here's what they look like. These are mine. I took pictures of. On the right center is the Uno. That's the one that most people get introduced to in the beginning. Above it are the Nano and the Pro Mini, which are smaller, have exactly the same computing capability as the Uno. Their advantage is their more compact size. And the Nano has more I/O pins available. And then on the left is the Big Daddy, the Mega 2560, which is bigger, has a lot more I/O pins, a lot more computing capability. Just a bit of comparison. The main three, Uno, Nano, and Pro Mini, they all use the same internal microprocessor chip. There's 32K of program memory. There are 22 I/O pins available on the Nano. On the Uno and the Pro Mini, they don't bring all those out to the edge of the board where you can access them. On some of the Pro Minis, they are available on pads in the middle of the board, so you can access them if you really want to. They all have 14 digital I/O pins and between 4 and 8 analog pins. 6 of those analog pins are also dual function and can be digital I/O pins. Just as a point of clarification, the digital I/O stands for input output. Digital is, it's either on or off. It's typical computer logic. It's either at ground level or at the VC supply level. It's on or off, high, low, true, false. It's binary. The analog will actually measure a voltage continuously from zero and whatever the supply voltage is. It scales that to 0 to 10,023 steps, so you could actually measure a voltage with it. The Mega 2560 has 256K of program memory, 70 total I/O pins, 54 digital, 16 analog. And I don't remember how many of the analog are dual function. I think they all are. All these boards have EEPROM. EEPROM is memory you can program. In your program that you're running on your Arduino can store data in the EEPROM. And when you turn the power off and turn the power back on, that memory is still there. Prime example of uses for this type of memory is setting your CVs in DCC decoders. All these boards have I2C and SPI interfaces for peripheral devices. We'll talk about those a little more. Most of the pins are multifunction. And there are a ton of peripheral devices available. And we'll go into a little more detail on some of that later. The software support. The programming language involved is a simplified version of C/C++ with the full power of the GNU C++ compiler available. So it's simple on the surface, but there's a lot of power behind it if you care to use it. The main program is called the IDE, which stands for Integrated Development Environment, which combines the text editor, the compiler, and program uploader all in one program. The compiler is what converts your human readable text into machine code. Those of you who may be have been involved in complex projects in C and other languages have learned about linkers and object files and things like that. All that's behind the scenes. Arduino takes care of it. You don't have to worry about it. Uploading your program to your Arduino is done via an ordinary USB port on your computer. Most of the Arduino boards come with a cable. The IDE and support libraries are open source and free to download. Many operating systems are supported: Linux, Windows, Apple's, Rasmussen, and others. Also, there's Arduino Create, which allows creating and uploading sketches from your browser without installing software on your computer. And programs are saved on the cloud. There are plenty of sketches. A little side note, in Arduino lingo, a program, and some people also may call it a script, they're called sketches in Arduino lingo. I'm used to calling them programs, so I may call them programs or sketches, but they are the same thing. There's a lot of examples out there. There are some you can just plug and play for applications, or you can modify them for your needs. Also, there are installable libraries that support numerous specialized devices and operations, and I'll talk a little more about some of those. A side note about the Pro Mini, it requires a USB to serial port adapter to operate. Here's an example of the IDE. This is what you get when you click on a new sketch. It has two built-in functions, which are part of the big part of the simplification. These two functions are setup and loop. And just as the comment says, the setup function, you put your setup code there, which runs once at the beginning when you first turn the power on, where some things need initialization. It's going to preset some values. Some definitions have to be done at runtime. That's all done in setup. The stuff we're doing in model railroading is real-time control. Um, and you sit there and do it constantly. So it does it by looping over and over again. Um, and then global variable, the space above the setup, um, global variables and global definitions are done there. One comment I'm going to make is that I'm not making an attempt to show you how to do it. This is not possible in a clinic like this to really teach you how to do it. I'm just hoping to give you the hooks so that you can go find out how to do it. Hardware, hooking it up. Arduinos have circuit boards they call shields, which plug onto the top of an Uno or on top of a Mega, or a Nano or Pro Mini will plug into a shield. There are many different types of specialized shields for specific functions. But the primary ones that I recommend and that I use are called sensor or servo shields. There's really no difference between them. It's just what people decide to call them. And these, to me, are the most versatile and what I recommend for most model railroading applications. The bottom line is that any devices you connect to an I/O pin on your Arduino is also going to need a ground or a power connection or maybe both. And the Arduino at best has one or two power and ground pins or connections. So the shields give you the extra ground and power pins that you need to hook these things up. And very conveniently, the pin pattern they use is the same pin pattern as a standard radio control model servo. So your servos just plug into the shield. Here's an example of some shields. On the top right is one version of an Uno shield. On the left is on the left is the Mega shield. On the lower right is what I recommend. The configuration I recommend for most model railroading application is a Nano on a Nano shield. You can see the groups of the 3-pin patterns for the servos. It has extra 4-pin patterns here for I2C or I2C, which we'll talk about later. Also has a pin field here for SPI. It has a barrel jack input and a voltage regulator on it, so you can power it by a wall wart. So this is my recommended configuration for model railroad applications. On the lower left is my own design special my shield. This is a version that has a Pro Mini on it. Here's the servo pins field. I like to use these 2x5 10 connector ribbon connectors. So I have those on the board. And then on the end is the circuitry for my network. And these 4 pins, 2 sets of 4 pins here are for I2C. Just when I talk about input output devices, I'm talking about push buttons, toggle switches, slide switches, rotary switch keypads, potentiometers, rotary encoders, there's light sensors, magnetic sensors, proximity sensors, LEDs, numeric displays, LCD displays, miniature video displays, servo motors, stepper motors, solenoids. You can interface with Wi-Fi, Bluetooth, RF, MQTT, just gobs of it. It's very versatile. Almost anything, just about anything you can imagine has probably been connected to an Arduino at one time or another. I want to mention I2C or I squared C. Um, I squared C is a two-wire bus interface developed for microcontrollers to interface to complex peripheral devices. And these are very handy, extremely handy with Arduinos because in model railroad applications, you run out of I/O pins before you run out of computing power. Upper left is probably the handiest. It's an I/O expander. There's several different kinds. On the end of the board, you can see there's the SDA, SCL pins that are the I2C signals, and it has power and ground, and an interrupt, which is beyond the scope of this discussion. And this has 16 input-output pins. And most of these can be configured to be any combination of inputs or outputs that you want. Down on the left is a PWM servo and LED driver. These are very neat in that you send the value to it for the pulse width to represent the position servo you want, and it drives the servo. The Arduino doesn't have to do anything. The servo libraries and software for driving servos with the Arduino, it can do it, and it does it very well. But it also takes up computing time and memory within the Arduino. With these PWM devices, all that is offloaded onto the peripheral device. So it can be an advantage, and they can also be used. And this is where their design intended function was to drive LEDs and be a dimmer. So you can also use them to drive LEDs and control the brightness. Upper right is an LCD display. The one in the picture has 2 lines of 16 characters of text. There's a larger version that's 4 lines of 20 characters. These are driven by the I2C. Make a note, look at the picture of the bottom of the board. And notice this little black piggyback board on it. That is the I squared C interface board. If you buy one of these, make sure you have that board. They are sold without it, and they will interface to an Arduino, but it will use up somewhere between 4, 6, or 8 I/O pins. It's much nicer to use the I squared C, and the library functions to support it are exactly the same. Upper middle is I squared C multiplexer. Basically what this does is to take the I squared C channel from the Arduino and divide it up into 8 individual I squared C channels. So if you have, say you have devices that have the same address, this way you could connect up to 8 of those devices. I should comment, go back up a second. Devices like these I/O expanders and the PWM driver, they have addresses associated with them. The IO expander is up to 8 different addresses, so you can connect 8 of them to the same I2C bus and control them individually. You could also tack an LCD display on that same bus and up to, gee, I forget how many. On the PWM, they goes up to like 60 or something. So that's really unlimited. Lower right is a this is actually a LiDAR device. It sends out an infrared, has an infrared laser that it shoots a laser beam out, and it actually measures the time of the echo coming back like radar or LiDAR with light, and it reads out the distance from 0 to 100 millimeters. I'll show you later how I'm using these on my layout as a detector for the presence of cars. Resources to get started. The first place you should go is arduino.cc. This is the official Arduino website. 3 key areas to look at there are go to the software tab or software menu item, and that's where you download the IDE. They have download instructions for all the platforms that are there. The other place is the documentation and the reference submenu. That's where you learn about the language and the libraries. The main page on the documentation shows you all the basic C language elements, plus it spells out all the built-in functions that are the simplifications that they have built into Arduino. The other important menu area is the community forum. That's where you can go to ask questions, search for answers. There's a lot of information there. Another important resource is Jeff Blenz's blog on Model Railroad Hobbyist. This is a link to it. If you remind me later, I'll post that in the chat for you. I also want to add is if you have any questions later on, when this program is over, feel free to email me. I will post my email in the chat if someone else doesn't do it for me before then. Hint, hint. Also, just an online search for Arduino Model Railroad. Use DuckDuckGo, Bing, Google, whatever search engine. They all show up a ton of sites with all kinds of information on Arduinos in general and Arduino applications for model railroading. Some are good, some are great, and some are not so. Another good way to get started is a starter kit. I'll talk more about that in a second. And sorry, I don't know of any books to recommend. I know there's a lot out there, and like on the online search, they probably run the whole gamut of good to bad. I didn't need them, so I never explored them, and I apologize that I can't recommend any. But like I said, a good way to start is a starter kit. Over on the left, you can see these are just a few that I, in about a 5-minute search, I found. Most of these are available on Amazon, which is probably the best source to go get them. Eligu, I'm not sure how to pronounce that, probably has the largest variety on Amazon. I have bought a couple little gadgets from from them through Amazon, and they seem to be a good outfit to do business with. I suppose all these others are good too, so I'm not really recommending them over the other, but they do have the biggest variety. Prices range from $18 to $70 and up. Um, the main difference, two main differences in price is one is how much they want to overprice their product, and the other one is how many uh, trinkets you get to play with in the kit. I've seen ads and looked at the specs for a model railroad specific starter kit that's out there. Um, I didn't see anything in there that really made it all that much better for model railroading, and certainly did not justify the difference in price in my mind. But what you get in most starter kits, you'll get an Uno um, and a wall wart to power it, the internet, the Ethernet, excuse me, USB cable. You'll get some jumper wires. We'll talk about these more later. Plug-in solderless breadboard, all kinds of gadgets. There's push buttons, LEDs, an infrared remote, sensor for the infrared remote, photo detectors, a relay, servos, stepper motors. Those are two big things for model railroading. I use servos for turnouts. Stepper motors can be great for animation. Um, they have digital displays. They have the LCD display. One word of warning: this may be one of the 8-pin jobs. So, um, and there's some push buttons and a motor, a propeller. I'm not sure what you do with that. Tape it to your beanie, I guess. Okay, we'll talk about the C and C++ language. The heart of the language used in Arduino is the C programming language with the added features of C++ that C++ brings to just plain sequential programming in C. It is not necessary to get into classes, methods, inheritance, public, private, destructors, this and all that's in C++. But it is available if you want to get into it. My estimation, if you can program a decoder with a Digitrax DT300 throttle or an NCE throttle with the push buttons, or if you've learned to draw 3D models that you can print with a 3D printer, I think you have the smarts to learn to do simple programming in C if you just want to take the time to learn it. When you're looking online, find a tutorial to learn to program in C, or another good way to learn is to look at examples and learn by modifying them. I'm sorry that I did not have time to go through and find a good tutorial on C. I'm going to be working on that. Email me later, and by later I mean days or weeks. And if I come up with a good one, I will be happy to share what I've learned. Quick pause for any questions before I move on to examples and stuff.
Ted, you made reference to a shield that you had made or your own design for servos and SDI.
Yeah.
Using with the Pro Mini. Is that available through one of the board vendors?
No, but I'm willing to share my design information. We can talk about that later. Okay.
Okay.
I will talk a little more about the board and other versions of it that I have.
Thank you.
Okay, so moving into what you can do and how you can do it. To start off, as a minimum, you could do something with just this much. Here we have the nano shield with a nano, a wall wart to power it, or as an alternative, you can see the white USB wall wart, and there's a USB cable. You can also power it that way if you wish. And then jumper cables. These are invaluable. Um, the type of connectors are called DuPont connectors. These things are called variously called 40-pin jumpers, DuPont jumpers. There's They're readily available on Amazon. They come in 4 common lengths, 100 millimeters, and I think it's 200, 250, or 150, anyhow, different lengths. They come in all LGBT varieties. There's male to male, female to female, and male to female. They generally come in a strip 40 wide. It's color coded with the standard brown, red, orange, yellow, the standard color code. And you can strip them down. These narrower strips here were stripped down from these wider. So they are extremely handy, and I use them a lot, and I recommend if you don't get, even if you get a starter kit that has a few in them, if you're really going to get serious with this, you may want to buy an assortment of those. So here's my first simple application. There's the nano shield with the nano, some DuPont jumper wires I stripped off, cut them, soldered them to the little wires from these traffic lights that I bought off of eBay. I got those either from EV models or We Honest, but they have these fine little wires, so I soldered them up to the DuPont jumpers and plugged them into the shield, and this is what we get. And I wrote a simple little program to, I can see my audio's on. Anyhow, that's what you can do. And if I go back here and look at the cost, just as a round number, I mean, careful shopper, you can beat these numbers. $2.50, $2.50. And I think this pair was, with shipping and stuff, they were probably $5. So $10, you got a pair of operating traffic lights that you could put on your layout. So you're gonna have traffic lights in your town. This one, I didn't even bother with the shield. This is just a crossing blinker. And same thing, I cut the DuPont wires, soldered them to the leads from the crossing blinkers, and I just plugged them in directly to the pins on the bottom of the nano, and I get crossing blinkers. Of course, if you're going to grade crossing, you want to you think about gates. This is a mock-up demo I made for a clinic I did a couple of years ago with my NMRA clinic at Mount Vernon. In case you don't recognize it, across here, those are the railroad tracks. And up and down the middle here is the street. There's a nano in a nano shield. I've stripped out cables off of DuPont jumpers to make the jumpers to connect these little photo detectors. I'll skip here to take a closer look. these little photo detectors, this has an infrared LED and an infrared detector. Um, these are really inexpensive. I think it was AliExpress one time. I saw 10 of them for $5. They have a sensitivity adjustment because depending on these depend on reflected light intensity. So the intensity of the reflected light will vary widely based on what's in the background. Um, the only drawback of these are 5mm LEDs, so they're kind of a pain to mount. The output from these is a digital input output, that, and they'll plug directly to the Arduino. The only problem is that the pin arrangement is not the same as the servo, so um, you'll have to cross a couple of pins to get the right connections. And the pins are identified, printed on the bottom of the board, so you just connect them up by the labeling. So let's go back to this. We have the 4 detectors. The two detectors on the outside edge actually be spaced out farther. When the train hits the detector, it starts the lights flashing and the gates going down. The 2 detectors closer to the road are there to keep the gate down until the train leaves. And here comes the train. This spilled the soup in the dining car. It's a pretty rough ride. Did you notice it cleared? And the gates go up, lights go off. And the train comes back. And I'll go back. Whoops, too far. Again, we talk about costs. These servos are like a couple bucks. So there's probably not less than $15 or so on what's here. The real expense is actually going to be getting working crossing gates in your scale that you can connect the servos to. Another application that there's a lot of interest in is lighting effects. And one of the basic ones is random lights turning on and off in a building to represent people moving around in the building and turning lights on and off as they move from room to room. I put this together as a demo, and I also wanted to bring up, if you really get serious, another thing you may want to get in, may want to obtain is a crimper for crimping the DuPont pins. If you're going to be doing a lot of wiring, this is very handy. What I did is I bought a bunch of these pre-wired LEDs that have a resistor built in, and I crimped DuPont connectors onto the ends of the wires, and then I plugged them in. I just made up this mock-up for this demo, and the software here is I just pirated one of Jeff Bunz's sketches, and I modified it a little bit. And the modification is I speeded it up by about a factor of 20, just to represent, just so you get an idea what the yeah, I don't know if I can kill my audio. This is my fancy hotel. This is the Ritz Hotel, if you didn't recognize it. Okay. Um, any questions about these examples before I go on to what I've actually done on my layout? Okay. So now I'm going to go into my layout and how I use Arduino on my layout. Um, I've been doing this for a while. I came into this as an electrical engineer and professional software engineer, so a lot of it's more advanced than a beginner, and it may even be more advanced than an average user might get into. But hopefully I'll try to simplify it so that you can follow what I'm doing and see the potential for yourself. I use a number of custom circuit boards, and as I mentioned earlier, I have developed my own network. Um, here's a simple, basic installation. Um, you see that in the photo of the track um, up here where this white styrofoam block is the north end of about an 11-foot long passing siding. About 3 feet down is this industrial spur, and I put in a crossover to aid in switching this industrial spur. So on the left, we see a control panel for that. I'm an advocate of push button route control um, rather than a toggle switch or 2 push buttons per turnout. My push buttons select a route. So this has 5 servos and 8 push buttons. You can see I wired it. This is a temporary panel. Um, you can see I wired it up and my favorite 10-pin ribbon cable. Um, here over on the lower left is my custom uh, my custom board. You can see that the control panel is plugged into to the ribbon cable connector, and then on the other side, the ribbon cable connector is plugged into a custom breakout board that and the 5 servos plug into that. I did this for testing purpose because I was plugging and unplugging things a lot, and it's a lot easier to unplug one connector for 5 servos than to connect the 5. Yeah, than to do the 5 connectors over and over. So if you look at the logic involved, the 2 on the ends are typical push the button and it throws the turnout. What happens if you push the button to go into the industrial spur, it'll throw that turnout, but it's so close that you really can't do any switching or anything unless the next turnout downstream is also thrown. So pushing that one button throws both turnouts. Same thing if you push the button here that connects it back to the main line. If you push that button, it also lines the turnout downstream from it. And if you're familiar with crossovers, you know that if you throw one turnout on the crossover, you almost always should throw the other turnout. So when you push this button, it actually will throw all 3 turnouts. If just for control, if you want to control for the crossover, you push the button in the middle, it throws the 2 turnouts for the crossover. Push the mainline button and it throws both crossover turnouts back to the main line. So the number of actual savings in the number of push buttons here is not that great, but it is a simple example. The next one is a much This is a much better example of the savings and the number of buttons with using the route control. The photograph on the right is a hidden storage yard that I had installed in my layout. It has since been removed. This is actually my first application of servos and the Arduino. You can see on the upper left, the control panel has 10 push buttons, and there are 7 servos that are connected. Just an example, if you push this push button down here for track 1, it actually will throw 1, 2, 3, 4, 5 turnouts with 1 button. And likewise, the others throw fewer, but you just select the track you want, push the button. The logic written in the program throws the turnouts for you. Here is an Uno shield on an Uno. Here's the 7 servos plugged in directly to the Uno shield. Now, one thing if you count wires and stuff, if there's 7 or 10 push buttons, you wonder where are the 10 wires? Well, I came up with this resistance ladder or resistance divider circuit that allows me to monitor up to 16 push buttons and monitor it with just 1 analog pin going into the Arduino. When you push one of these buttons, it sets up one of 16 different voltages on this pin going into the Arduino, and the software in the Arduino can look at that voltage level and determine which push button is being pressed. I wired this thing up on a piece of perforated board. This row of connectors across here is for connecting the push buttons. I've got either pins or screw connectors for the ground side of the push buttons. And down here are the 3 pins in that servo connector arrangement that plug into the Arduino: power, ground, and the voltage signal. Okay, when I mentioned I did my first microprocessor controller application on the model railroad was for this staging yard, and the control panel in the upper left represents the track diagram. The idea of this is the main line, the line down from the layout comes down on this upper track. You go down around partway around the loop and back the train into the staging yard. This was completely hidden, and the goal was to be able to operate it just by monitoring the lights. And like I said, I did this initially with a different processor board, hand wired all these LEDs and push buttons, and it had some problems, and I decided to do it over with Arduino. First thing, let's talk a little bit about what's on this board. There are 39 LEDs and 9 push buttons, and I did not cherish the idea of wiring up 48 devices again. So I designed these circuit boards, worked out this arrangement with these push buttons and the LEDs that'll poke through holes in 1/8" masonite, and I made this panel. If we go over to the lower left, you can see the back side of those circuit boards. The 3 red boards that are piggybacked onto the back of the panel boards are I squared C IO expander boards. 16 IO pins each, 3 of them, that's 48. That handles my board nicely. If you notice the traces down here, these are the 2 wires, the 2 signal lines for the I squared C, and they just go from this board to that board to that board. There are solder pads on the IO expanders that select the address. You have to excuse me a second, my throat's getting dry. And it connects to the Arduino with 4 wires, the 2 I squared C wires and power and ground. I use my favorite 10-pin ribbon cable just for convenience. Up above, you see one of my custom shields with a nano on it. These connectors down here are the I squared C connections. I'm trying to remember which. Oh yeah, and they're connected through the breakout board here. This is this gray cable coming off here is the connection for the control panel. The turnouts on this yard are powered by tortoises. These 4 devices, these 4 boards side by side here are they're dual H bridges, which are what you need to drive a DC motor like a tortoise. Each board can drive 2 of them, and they're connected through these ribbon cables up to these breakout boards and up at the top of the individual wires going out to the tortoises. Let's see. Oh, and the red board down in the middle here is another IO expander that drives the H bridges that drive the tortoises. One note is if you're going to drive a tortoise with an Arduino with H bridges like this, a very nice plug and play sort of arrangement. It takes 2 IO pins to drive a tortoise. And just some of the statistics on this staging panel. Like I said, there's 39 LEDs and 9 push buttons on the panel. I'll back up a second. On the panel, on the right, you see these amber and red LEDs. There are photo detectors that detect when the end of the train is approaching the end of the track. The amber comes on when it's about 1 car length, 4 or 5 inches. The red LED comes on when it's about 1 inch or so from the end. And like I said, there are photo detectors for each of those. The red LEDs that zigzag through here, these are at the fouling point. This is the point where if you leave a car on that spot, a car going by on the adjacent track might run into it. So these LEDs indicate clearance. And then also there's 2 other LEDs to indicate when your train has cleared these turnouts. So there are photo detectors for all of those. So the 9 push buttons, there's 16 photo detectors, 16 pins driving 8 tortoise machines. So that's for a total of 89 input and output pins. A lot of the concentration is taken care of by my network. But with all of that going on, I mean, that's a lot of I/O pins. And remember, I said you run out of I/O before you run out of programming power or memory. Uh, the software that runs all that takes up only 26%, barely over 1/4 of the program space in the Arduino. And it takes up 1/3 of the dynamic memory or the RAM. So there's a lot more horsepower in an Arduino than you need for a lot of model railroad applications. I mention this because you hear a lot of talk about people thinking you need to use, go to the Raspberry Pi or a Pi Pico, or there's a bunch of different 32-bit boards out there. Um, it's way overkill. An analogy I thought of is you need to move 2 boxcars. But if you could move those with a little yard goat, or if you wanted to move up to say an SW1500, that would be like moving them with that's like working with an Arduino. And then if you go to a Raspberry Pi, that's like getting out a UP Big Boy to move those 2 boxcars. So the dilemmas that I was facing, and I think some others might be facing, are how do you control turnouts from multiple locations? When you get into signaling, what do you do about a signal where the signal is here, but the detector for the track is 4 feet or 10 feet away? What if I want a remote display of the routes of turnout alignment or the signal aspects? Or then what about tying into to JMRI? Well, the answer that came to me some years ago is a network. Now, LCC could do it, and we asked why not, and why didn't I not use LCC? Well, I started on this implementation well before LCC equipment was available. I think my network's simpler and more flexible than LCC. And later, more recently, just in the last few months ago, I reviewed the LCC devices available from the LCC manufacturers, all one of them. And this is what I come up with. For 3 nodes that I'm working on, is a total of what I would need for LCC. I would need 3 of the railroad circuits tower LCC boards. I would need to drive servos. I would need an Tam Valley Octopus is probably one of the best options. And I came up with a total of $457. I did an estimate on my node boards and IO expanders, and I estimated high, and I came up with $100. So that to me is one incentive why I'm not considering switching. And like I said, for me, my network is a lot more flexible. I used to work with a guy that insisted we come up with a catchy name for products we were developing. So I came up with this for my network. I call it Simbab, which is a simple but adequate adaptable bus. And it is definitely the tinkerer's version of LCC. It is not plug and play. Oops. A word of warning, there's no software available for this. And am not, I'll coach, but I'm not providing software for it. So it's anyone who's not willing or able to program in C, C++ for Arduinos, this is probably not for you. However, I will add that the kinds of things I'm doing with this can be done with LCC. So what is it? It's a peer-to-peer bus. Any node can transmit or receive. All nodes are of equal importance. That's why it's peer-to-peer. Peers are equals, so they're all equal. It's a single twisted pair of wires that carries the data in both directions. The driver circuit is a simple open collector NPN transistor. It's essentially a wire-to-OR connection. Use a 5-volt signal level, standard serial 8-bit, one start, one stop, no parity. Idle state is a logic 1 or high idle state, just like standard serial, the standard serial port that's built into the Arduino, standard serial port that used to be on our computers, same in essence as RS-232. I've operated a test over, I have a 400-foot coil of a Cat3 phone wire, and I transmitted signals at 115K baud with no problems. And I've implemented this with the Arduino, this small 32K Nano Uno Mini, Pro Mini. Here's a schematic of the driver circuit. Transmit pin connects to an LM393 comparator that simply acts as an inverter to drive the transistor, which drives one side of the bus with a pull-up resistor. On my individual boards, I put 100K, so there's some pull-up there for testing. But when it's connected to the network, one node has a 390 ohm pull-up resistor, which is the terminating resistance for the network. The receiver is the other half of the LM393. It's just pretty much basically a high impedance 47K input impedance with a little bit of feedback for hysteresis. Drives the receiver pin on the Arduino. These 393s are open collectors, so there's a pull-up resistor to pull them high. I put an LED on it just so I can tell when there's activity on the bus. I said this bus is a twisted pair. I bought a 100-foot spool of each of these 24 gauge solid wire. I clamped one end of them in the vise. I unspooled all 100 feet out the length of my driveway, chucked them in the electric drill, and I twisted them. And then I ended up stringing it around my layout. My layout is a sort of a J shape. So I strung this around the layout, and I think what I haven't installed on the layout is about 60 feet of that. So how does it work? The software protocol, it's event driven. Inputs produce event codes, very similar to LCC. All intelligence is at the receiving end. When an event occurs, multiple receivers could respond to an event, or they could ignore the event. The packet format is expandable. Central control is not required, but it could be included. And JMRI interface is possible. Event code is event code packet is 2 bytes plus a checksum. Most significant bit of the first byte is a 0. That leaves 15 bits for over 32,000 event codes, which is adequate for all but the largest layouts. The MSB, the first byte of an expanded packet, is a 1. From there on, the packet length is whatever you want. You can do whatever you want with the remaining bits of the packet or more bytes, which makes it adaptable. Event codes are generally triggered by the state of change of an input, like when a button is pressed or the train enters a detection block or leaves a detection block. It's the change that creates the event code. On a modern world, things aren't happening that often. It's relatively low rate of event codes being produced. With the way I have it set up, I estimate that I could handle 1,200 packets per second. And 1,200 events per second is pretty active and or a pretty large layout. So one of the problems with a network like this is collisions, where two things try to transmit at the same time. My solution for collision mitigation is I transmit event codes twice and separated by each node has a different delay time between transmissions. So if two of them happen to collide on their first transmission, the retransmission will be staggered, so they should get the message through without a further collision. And also, and I'm in my detectors, like the fouling point detectors and such, I'm adding software so that periodically it will transmit event code to, in essence, repeat the state of that output. We get into some of the applications of the network. This was the first one I did, and it was experimental. I broke this up into 3 nodes, which I probably could have done the whole thing with 1 node. If you look at the track plan, I have this passing siding coming down. I have an industrial spur off of it, and then this other turnout here. It's a cutoff that to cut off to head into the staging, which is down at the lower, down at the bottom here. You see the track plan. There's 8 push buttons that I've actually hooked up. The 8 push buttons are connected to this this nano on one of my shields, and it's literally just double sticky taped to the back of this panel. And then I started out using RJ45s for the network connection, and this I have since changed to that the tap line that I showed you. So this node is the control panel. This node up here controls these the 3 turnouts up here at the end of the passing siding, and the node down below on the left controls controls these 2 turnouts. This node used to control the upper end of this passing siding, but I changed that and I'll show you that later. These two push buttons still control that upper end of the passing siding. So this is the node for, you look at the trap diagram on the lower left, you see there's the upper end of the passing siding. And then a little further to the left is the lead in to my yard, which is my former yard. I decided that I just did not like the way that was working. And this is all of this blue, and on this control panel, this lower part, if you may notice behind me, when I stop sharing, this control panel is gone. But this was an experiment using these, they're called tactile LEDs. It's a push button that has an LED built into it. The problem with them is the pins on them are very delicate, and you cannot, you would break them off if you tried to hand wire, so they have to be on a circuit board. So I made up a circuit board that could cut into strips, and it's hard to see, but there's these, you see these five are in a nice straight line. Well, that's this board up here, and these other two are mounted on this board. These are wired together into one of those I/O expanders, and the connection to the Arduino is this this 4-wired cable, which is the I2C cable. Off the picture on the same control panel are push buttons to control this left end of the yard entrance. And as luck would have it, there was a vertical support right in the way. And rather than try to route the wires around it, I tried connecting with this copper foil so that that the panel will still press right up against that support, and there's no bump or anything. So that's what the copper foil is about. And this other strip of copper foil up here with these resistors is because I made a stupid design mistake and forgot to include pull-up resistors for the push buttons. And then the node board itself is down below. You can see the I2C connection at the bottom, and then my ribbon cable and breakout board connection to the servos. So these push buttons are route control. These two buttons control that upper passing siding. The two buttons on that other panel control this turnout also. And when you throw the turnout with that other panel, the LEDs here change. And then another node, this is the node that has the servos for that left end of the yard. And this was an initial experimental installation. This was that board I made for those tactile LEDs. And I just stuffed it with these 8 buttons and wired them to this lash up with this ribbon cable, and this blue board on here is another I/O expander. And again, these resistors are taking care of my screw up and not providing pull-up resistors. But anyhow, these push buttons, ML6 is mainline 6, yard access 1, yard access 2 are these for these routes into the yard. The ISN stands for industrial siding. That's for this turnout down here. And just for the heck of it, I put in 2 buttons also to control that that same passing siding. Probably don't need it, but like I said, it's experimental. Yeah, you have to excuse me again. like I said, the blue yard, that blue yard trackage is all gone now. I've started a new smaller yard. It's going to be much more convenient and much more in keeping with the overall size of my layout. The yard I had before was 2 to 3 times as big as I really needed. So what's new? Um, ah, come on. There we go. Okay, my mouse clicking is all right. Here's one of my latest installations. This is my newest node board. It takes a nano. Here on the end is my the receiver circuit, and now for those, I've switched away from the RJ45s, and I use these little 2-pin JST connectors and drop wires off the network, like I showed you, where I just scrape the insulation off the bus wires and solder these drops. And the reason I'm using these and the reason the color is different is I bought a bunch of these that were pre-wired with red and black. I would have preferred the white and green that I use for the bus, but I'm stuck with the red and black. This like I said, this is my node. I call it a node board because it is a node for my network. I have a 5-volt regulator on it, so I power it with 12 volts. It has several pins brought out to 2 sets of 8 with the ribbon connectors. I2C, 2 sets of I2C connectors. One of the changes is this outside one with inserting jumpers in these pins. I can select whether the power going out is 5 volts or 3.3 volts, because some of these peripheral devices, like the ones I'll show you here in a second, run on 3.3 volts. And then these take care of 16 of the I/O pins. The other 4 other I/O pins, I have pads here where I can solder pins in. I just didn't populate them. And if you're counting, you'll follow that I'm 2 pins short. And the reason for that is I use 2 pins because I use software serial for the bus. I do not use the built-in serial port for a couple different reasons, which are beyond the scope of this. Anyhow, here's the installation. These are 2 of those I2C multiplexer boards that in essence create individual I2C buses. All this cabling connects to and all the detectors for the fouling point and those turnout clearance points are Iowa scaled engineering I2C or IR sensors, and they are they're not the full train spotter. They're just the infrared sensor on a little board, and you access them through I2C. One of the difficulties with them is they all have the same address, so you cannot connect multiples of them on the same I2C bus. You have to use a multiplexer like this. So that's what these are. These came from SparkFun. They just plug in, and these also require 3.3 volts. So all these wires go off to those sensors that are they mount from underneath in a 3/8 inch diameter hole. I'm sorry I didn't get a good photograph of those, but I did have a problem spot right here on tracks 6 and 7 in the staging yard. Now you can see here's a 1x2 riser right here, which means that right below this is a joist, and the L girder in this area is about directly below this rail. So there was no way I was going to drill a 3/8 inch hole up from the bottom. Oh, and then up above, this is the hidden staging. Up above, you can see it. This is about 8 inches or so is the upper level of the layout, which I can't get an electric drill in there. So what I did is I took one of those VL 6180s that measured distance, and I aimed it across the track. And the software looks at the distance of what it's seeing. Now, if what it's seeing is, 3.5 or 4 inches or farther away than that, then both tracks are clear. If what it's seeing is about 2.5 to 3 inches, then track 6 is occupied. And if what it's seeing is about an inch, inch and a half away, then track 7 is occupied. And I've got that set up, and that's working pretty well. So that was, I mentioned earlier, those I2C devices and the distance measuring. This is one application for them. On the right is another application. On the ends of the staging tracks, I have these mounted so they're looking down the track, and the software looks at the return. When it's farther away than 100 millimeters, both LEDs are off. When it's closer than 100 millimeters, the amber LED is on. And when it's closer than 20, 25 millimeters, the red LED is on. And these seem to be working pretty well. So I'm pretty pleased with the results. You can see this white paint. You can see one of the old photo detectors that I couldn't get out. I'm not sure. I think I super glued those in. Just a quick overview of the software. I divide the software into two main parts. One is I read the inputs, generate the event codes, and I transmit the event codes. That's one function. And in my main loop, that's usually just a function call, and that goes off and happens. The other part of it is receiving, is just to receive and respond to event codes. And even things that are happening in the same node, like what I showed you, the panel there that had both push buttons and controlled switch machines, the signal path is still out over the network and received. I do it that way because if I want to make a change, like I moved that one servo from the one node to the other node, it's just events on the network as the coupling between those devices. So I could do that with only changing the network signaling and response. One of the things, I have all these nodes and they're sharing event codes and stuff, is I created a master.h file, a header file that I do a define of all the event codes, and all the sketches in the nodes include that same master.h file. So that's how I keep track and make sure everyone's talking the same language. The goal was to keep the cost of the node board low so that cost was not an issue for adding a node. That's why I came up with the custom node board with the transceiver circuit. The initial one had sockets for a nano or pro mini with a variety of I/O. Um, like I said, I started out using the RJ45, but I got away from that. Did the twisted pair. Um, More and more, I'm using the I/O expanders and the PWM multiplexers. Um, it it it's it makes for a convenient way to hook things up, um, and in some cases the software is simpler. And particularly, I like the unloading the servo stuff from the Arduino. Because one of the problems with any of the servo libraries is the servos using timers and interrupts and stuff, and and that can interfere with some other functions, some other devices and functions on the Arduino. So if there's an opportunity to offload that to another device, I'll do it. And these PWM multiplexers are a good way to do that, and they're not very expensive. My goal is, well, my control panels will just connect with 3 or 4 connectors, 3 or 4 wires, either mount a node on the panel or use the I squared C or use that resistor divider. Um, so what are I headed in the future? Um, signaling. Um, signaling may require the implementation of a state machine. I have some ideas on that. If you don't know what a state machine is, it remembers something that's been set, so that um, when a thing is event driven, like the train moves into a detection block. Um, it only sees the event when it enters, and it sees another event when it leaves. And so you need a state machine in the software to remember that block is occupied. Now, like I said, I back up by repeatedly transmitting that state, but it still needs to remember that. Another thing that can be done is structure lighting and animation control. You could do this over the network. JMRI, I use a USB connection to the computer. I've installed a Mega 2650 to do that. I use the Mega 2650 because it has 4 serial ports, and uh, so I can use one of those for the network and the other one for the JMRI USB interface. With JMRI, there's all kinds of possibilities. It could interface to control turnouts by JMRI panel. Um, One idea that just hit me, I plan on using the JMRI's operations um, train operation software for generating switch lists and train orders and such. And one harebrained idea I have is when you push the build button on the JMRI ops to create the orders for a new train, to physically out on the layout on the depot is have the semaphore train order board raised to the or lower to the orders pickup position. So I don't know if that's possible, but that's just one of my pipe dreams. And then the other thing that's kind of a pipe dream is using software serial is advanced collision mitigation, where I could actually, with software serial, do a bit by bit test for collision. I don't know if that ever happened, but that is a possibility. And that is the end. And if there's anybody still awake, ask questions. Or you're so overwhelmed.
Well, I'll tell you, you covered an awful lot of material, Ted.
I tried to warn you.
Oh, listen,
Yeah.
I can't tell you how appreciative I am of it, because I keep hearing that young people coming into the hobby are going to stay in the hobby because of technology. And certainly this is one part of technology I think a lot of people may get interested in.
So Ted,
Yeah.
just a couple of quick questions. So, you developed basically your own bus version, which, obviously may have some cost advantages over the CAD bus that's used in LCC. But I mean, from the perspective of the rest of LCC, I've looked at LCC. LCC basically are these nodal processors that have a CAD bus between them, and the whole application structure of the architecture is based on a publish and subscribe model. I mean, basically what I think you've done is essentially begun a replication of that with what would be argued as a simpler bus that may be more cost effective related to a model railroad environment. But basically with simple Arduinos has a publish and subscribe model. Is that a fair statement of the kind of the whole bus discussion? Because I think it was very detailed, but I want to kind of bring it back to how it could actually be utilized by folks.
Yeah, it was. Yeah, like I said, I don't. I said this is a tinkerer's and a programmer's alternative to LCC, and I don't know for sure that many people would actually try to duplicate what I've done.
Well, I mean, the whole concept in the world now is you don't duplicate, you reuse. So, I mean, the question is, have you put the stuff up on GitHub so people can get it? Because I mean, the concept of saying, so the thought process here that I was thinking about when I listened to that, the last part of this, because for most folks here, that was probably, I mean, I'm assuming most folks it went over your head. The concept of bus structures and how you do buses and how you do distributed architectures is kind of a fairly advanced concept. But the interesting perspective is there were kind of two options there. One would be to kind of use the LCC structure and replicate it in your own code. I mean, what you did was basically replicated something different. And the question is it makes sense to kind of put that out somewhere where people can get it and try it and add to it? Because the basic underlying protocol should be the same. And then the other question I had, which is actually something that I started to think about as you talked, is if you look at the I2C bus, there actually are some extender chips for that bus, and there are some fairly simple ways to have Arduinos talk to each other using that bus. I was wondering if you considered that as an option as an interbus architecture instead of kind of a different bus that requires a whole set of characteristics.
Yeah, I touched on that. Well, it came up after I had started going this way.
Oh, okay.
I squared C is very much a master slave environment.
Yep.
It's very much a master slave environment. So, yeah, you could probably do it, but
you really wanted to create again the peer environment with
I wanted to do the straight peer-to-peer environment. Yeah.
Yep. With a publish and subscribe model.
And yeah, and that's the LCC concept also.
Exactly. Yeah.
And to me, that's the most flexible way to go about, especially an environment like a model railroad. And I've worked on bus environments, so I worked a lot in avionics. And, so some of them probably don't never recognize the ARINC 429 or ARINC 629, know what those mean, but those are bus environments that are used on airplanes. Yeah, like, yeah, I just see you can do communications between Arduinos, but it works best on a one-to-one or one master, multiple slaves.
And I have one question. It's Pat Regard here.
Mhm.
The use of the stepper motor, can it be used with the Arduino and the use of a turntable?
Definitely.
It would be strong enough in O scale?
Oh, no scale? Well, that particular little stepper motor that's in those starter kits, probably not.
You'd have to get a
But
bigger
you
one.
can definitely find stepper motors that will drive an O scale turntable.
And Patrick,
fact-
the way to think about a turntable, because we've been playing with this, is you can actually set up the turntable so you align it with rails
Mhm.
and you put inputs, which actually, so in other words, you can set the turntable up where you zero it at a point where it's on an inbound track.
Mhm.
And it's now counting as the stepper moves around. So
Then
you
you
can
set it.
move it, you can actually set up a couple of buttons that actually allow you to move it around manually and move it to a point and then enter a code that says, now it's aligned at that stepper point with this track.
Okay,
And then in the programming, and Ted can talk to you a lot about how to do this, you can actually make the decision to find the optimal path. But what you can do is you can decide that it never goes 360 degrees.
yep,
So it always, it starts here coming in and it either goes this way or it goes this way. And if you're in this stall here and you want to go to a stall over here, it actually goes all the way around. And by doing that, now you can actually just have two wires coming out at the bottom. You don't
yeah, that's
have to
my,
have the rails for power because you control the directionality in the software. It's a really interesting set of thought processes. You can auto align, and then all you have to do is move it to the main track, hit a 0, and now it's realigned for the future for any movement. So yeah, it's a really powerful tool for that.
good.
And
If
Ted,
you guys want the code for exactly that, I have it.
there you go. Exactly.
That figures.
We we did this
tell you
on our
something.
we did this on our HO club layout with I think it was 9 stalls, and we did exactly that. We used it as with a code and
Yep.
one of the guys who is an Arduino guy. Now I'm going to say something to all of you electronics guys. That's fantastic. You love that shit. But the hobby is model trains. You're in another rabbit hole. We have to make this really easy for all us grandpa guys who are into model railroading.
Well, my son-in-law is quite knowledgeable and he's in robotics, so he's gonna set it up.
Well, yeah, he'll help you out.
But the cool thing about it, Clark, is that you guys have a sketch that somebody wrote. And if that's published, then somebody can start with that. And so what's interesting is that actually the thought process here is it allows you to simplify
Mhm.
a lot of the underlying things that we used to spend a lot of time trying to do in other ways and maybe focus more on modeling.
Well,
Right.
that is a point. But as I always say to guys in electronics who know what they're talking about, explain it in the fact that grandpa has no effing idea. He's just learned how to use the VCR.
Grandpa doesn't even know how to use the VCR yet. But I will tell you this.
Could I reclaim my clinic?
You sure can, Ted.
All right. Back to the person who was asking about the circuit board. Email me and we'll talk about it.
Okay.
Okay.
All right, thank you, Ted. It's going out to you now.
Also, I want to emphasize that. Well, first of all, I know this is not for everybody.
Yeah.
And I'm not advocating that a lot of you get in there and try it. I was just showing what's available and what can be done. On the topic of turntables, I've written a lot of notes and did a lot of designing and trying to figure out how to power a turntable. And when Uncle Sam sent me a COVID check last spring, I bought a Walther's automated turntable and the advanced control module. It is doable.
Well, Ted, I have got it working now, but I've got it on the power to the turntable all set up and working, but I don't have a stepper motor on it. And my son-in-law wants me to put a stepper motor on it, so it simplifies the turning radiuses.
Yeah.
He says he can make it go forward and reverse if I want.
Right.
So I said,
And
okay.
like Clark was saying, if you connect it to an Arduino and
Yeah.
you really want have a single point reference to tell it to know where it is.
That's right.
Point. And then it monitors where it is by counting steps. And these steps are pretty small. It's like the fraction of the width of the rail. So
That's what he was saying.
and the logic and the way to set up a Walther's turntable is pretty much the way what Clark was describing. Now, a friend of mine, an O-scaler, has one of those system that's been around for ages, New York or something like that.
Oh yeah, yeah. New York indexing, I think it's called.
And that thing is, when it's working, it's beautiful. But if it gets lost or the programming gets screwed up, he has to go through from the beginning and reprogram every stall in order, or from where the default is. It's the way it's programmed. It's got to be in sequence. The way the Walters is done, and the way Clark was describing, the way a typical programmer would program it in an Arduino to control it, it would be easier to reprogram if you want to change it, because you line it up manually and then you push the button and say, this is track 7. And next time you punch track 7, that's where it'll go.
That's what he told me.
Yeah.
Yeah, that's how it.
And that New York system is not like that.
Yeah. Yeah, if you guys need the
I'd love to
code.
get my hands on one of those and reprogram it. Put an Arduino on it.
Thanks, Ted.
Yeah. In the framework of what I do with the NMRA 4th Division of the Pacific Northwest region, I did about 12 sessions this spring on Arduino, and I'm going to be very likely starting those in the fall. And there's we get down to the nitty gritty and teaching you how to do things and answer questions. If you're interested in that, 1, send me an email, and 2, if you want to go to that avenue and get on those sessions, is access the 4th Division PNR newsletter, online newsletter. It's called the Grab Iron. If you do a search for 4dpnr.org, that should put you there. And I will be posting announcements there if and when these classes start. I'm still a couple people short of the threshold where I think it'd be worthwhile, but I'm making that available. And like I said, I'm always available on email to ask questions. And I see that Ken just posted my my email address again. So, and Ken can attest. I talked him to sleep a few times on these classes last spring.
Well, Ted, I want to thank you again for taking the time to put this together. I really do appreciate it, because to me, I hear all the time that electronics and technology are something that's going to help the young become model railroaders. And I've always believed is first you're a model railroader, and then if technology can keep you being a model railroader or make model railroading more fun for you, then I'm all for that. So trying to keep track of what's happening in the hobby is what this is all about. And I hope that everybody enjoyed the presentation as much as I did. Thank you so much, Ted.
You're welcome.
Well, that's it for this evening. Next time, August the 21st, Saturday, is going to be a build along. I mean, with David Rares. He's going to finish up the card model that Paul Egret designed. Clark Cooney is going to show us how to build rocks. And our featured modeler is the My Build. That's you and what you're modeling and what you have modeled. And I'm really looking forward and hopeful that a lot of you will participate in that. I've talked about it for a long time on the show, and I've been disappointed in the past about the number of modelers who have taken advantage of it. I hope that you'll take advantage of this one Saturday and participate. I hope you enjoyed tonight. I hope you learned something. I hope you didn't sleep through Ted's presentation and have a better understanding of some of the potential that's available by bringing electronics into our hobby of model railroading. Again, I encourage you to go and subscribe to our website, newtracksmodeling.com, so that you'll get the login information on future shows and also be eligible to win the door prizes. Thanks so much for being here this evening. As I said, hope you learned something and had some fun, and happy modeling until next time. Thank you so much.